Hello everybody, welcome to Simplified in 5. Today we're going to talk about composite design pattern. So let's first see in which problem scenario you would be using composite design pattern. So if you are creating a collection of objects and you don't want to treat the individual objects as well as their group or composition differently, you want to treat group as well as individual objects equally, then you should be using composite design pattern. So if you want to create a tree like structure of objects, or if you want to create whole part hierarchies of objects, then you should be using composite design pattern. Now let's see how to implement this design pattern. So you first have to identify the component interface, which would be common for all of your objects. You have to identify the primitives as well as you have to identify the composite classes, which would be creating collection of these primitives. Then you should provide facility to add and sometimes remove the primitives from composite class. At the client side, what you would be doing is just add primitives to the composite, create a composite class which actually has a group of primitives, and then perform operations over composite class. These composite classes will in turn perform the same operation on all its contained primitives. So now let's see a simple example. So here let's say we want to write a program where we want to draw a picture of house and a tree. So we define our component interface such that every object is a drawable, and it should provide provide implementation to draw, and we should also provide the facility to add the drawable object to a particular class. So this would be used mostly by the composite class. So it's not a pure virtual function, whereas draw is a pure virtual function. Now let's see for home. uh, let's say you want to have windows, doors and walls as your primitive classes. So each of these primitive class will provide its own definition for draw. So window, door and wall, these would be my primitive classes for home, and my home would be the composite class, which again derives from class drawable. And in this class what I would have is a private member which is a vector. It would contain a vector of all drawable home components, and in my draw operation what I would do is uh, I would iterate over all the components, all the home components, and call draw on each of them. And in that, I would say yes, I'm drawing home, and I have also given the facility to add drawable home components. Similarly, for tree, trunk, branch, and leaf, let's say these are my primitive classes. So each of them would have a separate definition for draw. So trunk, branch, and leaf would have their own draw methods, and tree would be a composite class containing trunk, leaves, and branches. So this will again in its draw operation, what it will do is it will call draw on each of its components. Now let's see a picture class which would be a composite of home and tree, which would be your end product. So here it will again have a vector of picture components, and in the draw method it will call draw on each of its components, similar to other composite classes. So this is a very simple implementation. Now let's see at the client side, or in your main, or in the main of your program. So if you're not using composite, what you would do is you would create objects of windows, you would create objects of door and wall, and call draw on each of them, and in the end you would say drawing home. Similarly, with tree components like trunk, branch, leaves, you would call draw on each of them, and you would say I have drawn a tree, and in the end you would say I have drawn a picture completely. Instead, what you could do with a composite design pattern, you would actually create objects of primitive classes, one more classes here also, but you would also create objects of composite classes like home and tree. Here you can see in bold, for home you are adding objects of windows and walls and doors, and for tree you don't actually call draw on home because it's not your final composite object. For tree also you create objects of trunk, branch and leaves, and uh, add them to tree. And in the end, in picture you add the objects of tree and home, and you just call draw on your picture. So what it will do is a pictures draw would call draw on home as well as tree, and in homes draw it will call draw on windows, door and wall. So this will actually draw your complete picture. So this would actually help you to treat your individual objects as well as composite objects equally. Now let's see 5 key things you should be remembering about this design pattern. So when you use composite design pattern, you actually create a recursive composition of objects. So everything is a drawable object here. Starting from windows, doors, up to picture, everything is a drawable object. So you actually create a composition of drawable object within a drawable object. So that's how you get the recursive composition. So a composite class contains primitive class objects, and each of which can be a primitive or a composite itself. Like home contains primitive objects like windows, doors, etc. Whereas picture, which is a composite object, it contains composite objects like tree and home. Now, the other important thing is composite has a one-to-many relationship with primitive objects. So a home can have many walls, many windows. Similarly, a tree can have many branches, many leaves, and so on. Similarly, you can in your picture you can have two homes, multiple trees, and so on. So composite has a one-to-many relationship with its primitive objects. Similarly, composite class uses polymorphism to delegate operations to its contents. So here we saw that in pictures draw, it calls draw on home as well as tree. So that's how it uses polymorphism to delegate operations. And in the end, composite as well as primitive classes both derive the or implement the composite component interface. This is the very important thing to remember, because both composite and primitive classes have is a relationship with component, which is drawable in this case. So everything is derived from drawable. So your primitive class as well as the composite class both are derived from component interface. So these are the 5 key things you should be knowing about composite design pattern. So thanks for watching and hope this helps.